In 1997, a network of secret microphones picked up a sound louder than anything alive should be able to make. It came from somewhere deep in the Pacific, in water colder and darker than almost anywhere people ever go. The scientists who first pulled up the recording didn't have an answer for it. Nothing in their files matched. They gave it a name that sounds almost silly: the bloop. What it took to explain it wasn't silly at all. Sound moves about 4 times faster through water than through air. That single fact changes everything about how this ocean works. A loud enough sound down here doesn't just travel a few miles. It can cross an entire ocean basin.
For decades, a hidden chain of underwater microphones has been listening to that sound. Most people have never heard of it.
This is a hydrophone. It hangs on a cable running down to the seafloor, and it just sits there, listening. It wasn't built for whales or earthquakes. It was built for submarines, during a war most people alive today never lived through. This is the story of the strangest sounds this ocean has on record, and how, one by one, most of them got explained.
In the 1950s, the U.S. Navy built a system meant to track Soviet submarines crossing the Atlantic and Pacific. They called it SOSUS, Sound Surveillance System. Rows of hydrophones planted across the seafloor at choke points in both oceans.
For nearly 40 years, it stayed classified. It sat there listening for the faint hum of a submarine engine. When the Cold War ended in the early 90s, the Navy handed part of this network over to civilian scientists. Overnight, oceanographers had access to microphones far more sensitive than anything they'd ever had before. NOAA, the National Oceanic and Atmospheric Administration, started using this gear to listen for natural sounds instead. They expected whale songs, earthquakes, ship engines. What showed up sometimes went well beyond that. In the summer of 1997, hydrophones scattered across the eastern equatorial Pacific picked up something they hadn't heard before.
Sensors more than 3,000 miles apart caught it within seconds of each other.
That alone told researchers something. Whatever made this sound had put out a serious amount of energy. The sound climbed in pitch for about a minute, then dropped off. Nobody on the team had a recording quite like it. They called it the bloop, half as a joke. The name stuck harder than anyone on that team could have guessed. It would go on to become one of the most talked about ocean mysteries anywhere on the internet. By timing the delay between each hydrophone, researchers worked out roughly where the sound had come from.
It pointed to a spot near 50 degrees south, 100 degrees west, deep in the southern Pacific.
That's roughly halfway between the tip of South America and New Zealand, about as far from land as you can get on this planet. It's one of the most remote patches of water on Earth. No ship passes through there by accident. What made the bloop stand out wasn't just where it came from, it was how loud it actually was. It was several times louder than the loudest blue whale call ever recorded, and the blue whale is the biggest animal we know of. If something biological made this sound, it would have to be bigger than a blue whale. Nobody had a candidate.
No known animal, alive or extinct, was thought capable of putting out sound at that volume and pitch together.
Once this leaked out to the public, people filled in the blank science hadn't closed yet. Giant squid theories showed up first, then talk of some undiscovered species. Then people started comparing it to horror movies. A few outlets ran with fictional sea monsters as if the recording proved they were real. It didn't prove anything of the sort. While all that noise spread online, the actual scientists kept working through the data quietly, one recording at a time. Over the next several years, NOAA kept expanding this hydrophone network across the Pacific and the Southern Ocean. As that network grew, they started picking up other sounds with the same basic shape as the original bloop. The key detail was location. These newer sounds were coming from water much closer to Antarctica. That gave scientists their first real lead on what might have actually caused the original recording. When a slab of ice this size fractures under its own weight, it can make a sound very close to what the bloop looked like on paper. Scientists call this an icequake. Same basic idea as an earthquake, just happening inside a moving glacier instead of solid rock. When ice sheets this large crack, shift, or calve, they release a huge burst of energy into the surrounding water. Cold seawater carries that energy efficiently, far enough for a hydrophone thousands of miles away to pick it up clearly. By around 2005, NOAA had gathered enough of these comparisons to reach a solid conclusion. The bloop most likely came from a large icequake, tied to ice breaking loose somewhere near Antarctica. The pitch, the length, the volume, all of it lined up with what an event like that would actually sound like. Even after that, the bloop stayed one of the most searched ocean mysteries online, years after the science had already settled it. That said something about how a good mystery can outlive the explanation that ends it. It also says something about how science actually works. It took about 8 years to go from recording to answer. Nobody rushed to a conclusion before the evidence actually backed it up. That's not a flaw. That's how it's supposed to go. The bloop turned out to be just the start. A handful of other odd sounds came out of that same expanding network. One of them had actually been recorded even earlier. This one is still, to this day, harder to pin down.
Researchers called it upsweep, after the shape of its tone, a narrow sound climbing steadily each time it repeats.
Unlike the bloop, this one wasn't a single event. It's been recorded continuously since 1991.
It happens several times a minute, and it gets noticeably louder during certain times of year.
It tends to peak in spring and fall. Early researchers noticed that pattern and couldn't immediately say why. Using the same timing trick from the bloop, they traced upsweep to a specific stretch of the Pacific. That spot sits near a stretch of underwater volcanoes, somewhere between the Pacific-Antarctic Ridge and New Zealand. There are dozens of these seamounts and vents scattered across that stretch of seafloor, active and largely unmapped.
Most researchers now think upsweep comes from geological activity down there, rather than anything alive.
The leading idea points to magma meeting cold seawater, producing this exact rising tone over and over again. Seasonal changes in water temperature down there might explain why the sound gets stronger in spring and fall. Even with a solid theory, researchers have never nailed down exactly what's producing this sound down there.
Upsweep is one of the few sounds on this list that's still, honestly, an open question.
That's worth saying plainly. Not everything down here has been wrapped up with a neat answer.
NOAA still monitors upsweep today, decades after the first recording, hoping more data eventually settles it.
One interesting detail: the signal has gotten quieter since researchers first started tracking it back in the 90s.
Some researchers take that as support for the volcanic theory, the kind of thing that would naturally taper off over time. Others point out that a pattern lining up isn't the same thing as proof. Fair point, and worth remembering. This is what real science looks like up close. Careful, slow, willing to say we're not sure yet, when that's the truth. To understand why these sounds travel so far in the first place, it helps to know something about the water itself. About 3,000 feet down, there's a specific layer where temperature and pressure line up in a particular way. Scientists call this the SOFAR channel, sound fixing and ranging. Sound gets trapped inside it and barely loses any energy. Instead of spreading out and fading, the wave bends gently back and forth inside that layer as it travels.
A loud enough sound entering this channel can, in theory, travel all the way across an ocean basin before it finally fades. That's the whole reason an icequake off Antarctica could show up clearly on a hydrophone 3,000 miles away. Military researchers found this channel back in the 1940s, originally hoping to use it to find downed pilots at sea. That same trick, discovered for wartime rescue, is now the reason scientists can study whales, quakes, and mystery sounds at all. Blue whales and fin whales actually use this channel on purpose, sending low calls across entire ocean basins. It lets whales separated by hundreds, even thousands of miles, potentially hear each other. That's hard to picture, but it checks out. Once you understand that channel, a lot of these mystery sounds stop sounding so mysterious right away. They didn't need some impossibly huge creature behind them. They just needed a strong event inside a channel built to carry sound far. The bloop didn't need a monster. It needed a big enough crack in the ice and the right kind of water to carry it. That distinction matters. It's the difference between actual science and a guess dressed up to sound scarier than it is. With that groundwork in place, we can look at a few more strange recordings picked up by this same hydrophone network.
Not every one of these came from ice or a volcano. Some needed a completely different kind of explanation.
In March of 1999, hydrophones caught a sound strong enough to register across most of the Pacific network at once.
It lasted only about 15 seconds, but the shape of it suggested something moving fast through the water.
They gave this one a name too, Julia. Several sounds on this list ended up with names like that, almost by habit. The acoustic signature closely matched something very large, moving steadily through open water.
The leading theory points to a massive iceberg grounding, likely scraping against the seafloor somewhere near Antarctica.
When ice that size grinds against rock and sediment, it can put out a strong, sustained sound through the surrounding water. Carried through cold water and that same SOFAR channel, that grinding contact lines up well with what Julia actually sounds like. Unlike Upsweep, researchers feel pretty confident about this one. Iceberg grounding is a well-documented, well-understood behavior. Events just like it have actually been observed and filmed elsewhere, which gives this explanation real, solid footing. Julia went from unexplained to well understood faster than most sounds on this list ever did. That pattern, icebergs producing loud, distinctive sounds, would end up tying together a couple more recordings on this list. That same year, back in May of 1997, hydrophones picked up a sound that behaved very differently from the others. This one dropped steadily in pitch over roughly 7 minutes. Long, slow, nothing sudden about it at all.
Researchers named it slowdown, which is exactly what its pitch did across the entire recording.
Its acoustic profile matched large-scale ice movement, the same broad category as the original Bloop recording. Researchers now think slowdown likely came from a large iceberg calving away from an Antarctic ice shelf. As a slab that size pulls away and starts its slow drift into open ocean, it makes exactly this kind of long, sustained sound. That same year gave us one more notable recording, picked up in October of 1997, and this one sounded different again. It came as a series of narrow tones repeating in an almost mechanical rhythm, over and over throughout the recording.
Researchers called this one train, after the rhythmic, repeating quality that stood out the moment they first analyzed it.
Like Slowdown and Julia before it, researchers eventually traced train back to ice activity near Antarctica as well. The likely cause was repeated grinding contact between ice and the seafloor, which would explain that steady, rhythmic pattern.
By the early 2000s, a clear pattern had come out of all this patient work with the data.
Most of the strange sounds recorded in 1997 specifically traced back to Antarctic ice activity of one kind or another.
That actually makes sense. 1997 saw a lot of documented ice shelf activity in Antarctica, confirmed through separate records. That kind of independent confirmation matters. It's what turns a good guess into an explanation you can actually stand behind. This is how mysteries like these actually get resolved. Not with a single dramatic reveal, but by matching data from different sources. One acoustic recording rarely settles anything on its own. It needs something independent to check it against. So far, we've covered 4 of the ocean's most talked about unusual sounds: the bloop, upsweep, Julia, and slowdown. 3 of the 4 now have solid, well-supported explanations behind real physical evidence. Only upsweep is still up for debate, its exact cause still argued over by the people who study it closest. 3 explained, 1 still open. That ratio tells you more about real science than most headlines ever bother to. A lot of coverage online makes it sound like every strange ocean noise is a monster just waiting to be discovered. The real story is better than that. It's careful people slowly closing gaps in what we understand, one sound at a time. We're going to keep going with a few more recordings that join this same growing catalog over the years. Not everything on this list came from ice or volcanoes. Some of it came from something plainly, unmistakably alive. In August of 1997, hydrophones picked up a sound with clear, recognizable biological features. They called this one whistle. Its pattern matched known whale calls closely enough, though the exact shape was a little unusual.
Researchers generally consider whistle one of the least mysterious entries on this list. Almost certainly a large whale.
We mention it mainly to show the range here. Not every strange recording turns into a years-long puzzle. Some sounds take years to explain. Others line up with what biologists already knew almost immediately. That range, from solved fast to still debated, is really what defines this whole catalog of odd recordings. It's worth stopping here and asking why so many of these recordings happen to come from that one specific year. 1997 fell right in the earliest years of civilian access to this newly declassified military hydrophone network. Researchers were basically hearing this ocean clearly for the first time. Sounds that had probably always been there. None of this started happening in 1997. It just became audible to people for the first time that year. The ocean was never actually silent. We just didn't have the tools yet to listen closely enough. That's still true today. Modern hydrophones, far more sensitive than what existed in the 90s, keep turning up new sounds.
That ongoing work keeps this catalog growing, even as some of the older mysteries finally get their answers.
We've now walked through how the bloop went from complete mystery to a well-supported explanation. We've looked at Upsweep's ongoing uncertainty and traced Julia, Slowdown, and Train back to ice near Antarctica. We've traced the military history behind the network that made all of this listening possible in the first place. And we've covered the SOFAR channel, the specific physics that lets these sounds travel such remarkable distances at all. That's a solid foundation for everything else this documentary is going to cover from here. There's still one recording left to cover, and it's genuinely different from everything we've talked about so far.
This one isn't geology at all. It's a single living animal, calling at a frequency no other whale shares.
That story is going to take us somewhere the first 4 sounds didn't. It deserves its own chapter. For now, let's take a breath and think about what these first recordings have actually taught us. None of it turned out to be supernatural. It's geology, biology, and physics, things science can actually explain. That doesn't make it any less amazing. If anything, understanding it makes it more impressive, not less. Knowing that ice cracking off Antarctica can be heard 3,000 miles away says something about how connected this planet really is. We'll carry that with us into what's still ahead, including one recording that connects to something happening right now. 2 more sections are still ahead, each one bringing us closer to a full, honest picture of what this ocean sounds like. We'll take everything we've covered here and keep building on it, piece by piece, from this point forward. This network is still down there right now, listening across several ocean basins at once, 24 hours a day. Every year it picks up new recordings. Some get explained quickly, others end up sitting alongside Upsweep, genuinely unresolved. This isn't a closed book from the 90s. It's an active field of study, still turning up new material every year.
Researchers keep publishing new findings, refining old explanations, and sometimes revising things once thought settled.
Being willing to update an answer when new evidence shows up is exactly what good science is supposed to do. We've tried to hold to that same standard throughout everything covered in this first section. Now we're headed toward the sound that ended up meaning more to people than any acoustic mystery ever had before. This shift from geological puzzle to something a lot more personal is a real turning point in this whole story. That story ended up reaching people who never followed ocean science before. It became famous well beyond the research community. We'll get into that carefully next, respecting both the science behind it and why it struck such a nerve with people. For now, we've laid out a solid, honest section covering how this whole catalog of sounds got started. We've traced the bloop from mystery to answer, sat with Upsweep's uncertainty, and connected the physics that ties it all together. We didn't pretend we knew more than we do. We tried to give equal weight to what's settled and what isn't. That's probably the most useful thing this documentary can offer, honestly, across its entire runtime. We're moving on now, taking everything from this first section into the next part of the story. The network that caught the bloop is still running right now, somewhere beneath the calm surface above us. Right now, somewhere out there, a sensor is recording something researchers haven't had time to look at yet. That's the fun part of this whole field, honestly. Mystery keeps arriving faster than answers do. We find that exciting rather than frustrating. There's still real discovery waiting out here for anyone willing to look. That brings us to the end of a solid first section, built on real evidence and careful, patient work. It sets us up well for a wider, more personal look at the ocean's single most famous recording. We're grateful for the researchers whose careful work made any of this understanding possible in the first place. This is the beginning of a story that ended up reshaping how a whole generation thought about the ocean's hidden voice. We're carrying that beginning forward into a section that's going to feel a lot more personal than what we just covered.
We've met the bloop, understood through years of patient science instead of speculation.
We've sat with Upsweep, letting it stay uncertain rather than forcing a confident answer where none genuinely exists. We've traced Julia, Slowdown, and Train straight back to Antarctic ice, backed up by independent satellite evidence. We've walked through the SOFAR channel, the hidden physics letting sound cross distances most people would never expect. Put together, that's a complete, honest picture of this catalog's earliest chapter. It earns real recognition. We're carrying that forward now into the next section and its central story, one that hits differently than everything before it. That story doesn't start with an unexplained event. It starts with a single, consistent frequency, recorded again and again across 4 decades. We're moving toward that story now, grateful for what this first section's patient work has already shown us. We've come a long way from the Cold War's secret listening network to a genuine, working understanding of what it recorded. Knowing that ice cracking off Antarctica can be heard 3,000 miles away says something about how connected this planet really is. We'll carry that with us into what's still ahead, including one recording that connects to something happening right now. 2 more sections are still ahead, each one bringing us closer to a full, honest picture of what this ocean sounds like. We'll take everything we've covered here and keep building on it, piece by piece, from this point forward. This network is still down there right now, listening across several ocean basins at once, 24 hours a day. Every year it picks up new recordings. Some get explained quickly, others end up sitting alongside Upsweep, genuinely unresolved. This isn't a closed book from the 90s. It's an active field of study, still turning up new material every year. Researchers keep publishing new findings, refining old explanations, and sometimes revising things once thought settled. Being willing to update an answer when new evidence shows up is exactly what good science is supposed to do. We've tried to hold to that same standard throughout everything covered so far in this documentary. Now we're headed toward the sound that ended up meaning more to people than any acoustic mystery ever had before. This shift, from geological puzzle to something a lot more personal, is a real turning point in this whole story. That story ended up reaching people who never followed ocean science before. It became famous well beyond the research community. We'll get into that carefully next, respecting both the science behind it and why it struck such a nerve with people. For now, we've laid out a solid, honest section covering how this whole catalog of sounds got started. We've traced the bloop from mystery to answer, sat with Upsweep's uncertainty, and connected the physics that ties it all together. We didn't pretend we knew more than we do. We tried to give equal weight to what's settled and what isn't. That's probably the most useful thing this documentary can offer, honestly, across its entire runtime. We're moving on now, taking everything from this first section into the next part of the story. The network that caught the bloop is still running right now, somewhere beneath the calm surface above us. Right now, somewhere out there, a sensor is recording something researchers haven't had time to look at yet. That's the fun part of this whole field, honestly. Mystery keeps arriving faster than answers do. We find that exciting rather than frustrating. There's still real discovery waiting out here for anyone willing to look. That brings us to the end of a solid first section, built on real evidence and careful, patient work. It sets us up well for a wider, more personal look at the ocean's single most famous recording. We're grateful for the researchers whose careful work made any of this understanding possible in the first place. This is the beginning of a story that ended up reshaping how a whole generation thought about the ocean's hidden voice. We're carrying that beginning forward into a section that's going to feel a lot more personal than what we just covered.
We've met the bloop, understood through years of patient science instead of speculation.
We've sat with Upsweep, letting it stay uncertain rather than forcing a confident answer where none genuinely exists. We've traced Julia, Slow Down, and Train straight back to Antarctic ice, backed up by independent satellite evidence. We've walked through the SOFAR channel, the hidden physics letting sound cross distances most people would never expect. Put together, that's a complete, honest picture of this catalog's earliest chapter. It earns real recognition. We're carrying that forward now into the next section and its central story, one that hits differently than everything before it. That story doesn't start with an unexplained event. It starts with a single, consistent frequency, recorded again and again across 4 decades. We're moving toward that story now, grateful for what this first section's patient work has already shown us. We've come a long way from the Cold War's secret listening network to a genuine, working understanding of what it recorded. That's real, hard-earned understanding of sounds once considered completely, permanently mysterious. We're carrying it into what's left of this documentary, and toward a complete, honest conclusion by the end. We owe real thanks to every researcher who worked through this data patiently, resisting the urge to guess too early. Next, we meet the loneliest whale in the world, and ask whether science has really understood her silence. That's part 2. In 1989, a Navy hydrophone picked up a whale call unlike anything on record. It's still calling. Every blue whale on Earth calls somewhere between 10 and 40 hertz. Every fin whale calls around 20. This whale calls at 52 hertz. Nothing else in the ocean answers back at that pitch. A bioacoustics researcher named William Watkins first flagged this signal in his data that year. Watkins worked at Woods Hole Oceanographic Institution, studying whale calls picked up by the same Navy hydrophone network from Part 1. This call kept showing up, year after year, always at the same frequency, always alone. No other whale call on the network ever matched it. Not once, in over a decade of listening. Watkins kept tracking it, not as a side project, as a genuine, long-term research effort spanning years. By the mid-1990s, he had years of recordings, all from the same source, all at the exact same pitch. In 2004, Watkins published a paper laying out 52 hertz whale in scientific terms for the first time. 12 years of recordings. One consistent signal. A single animal, as far as the data showed. That paper is where this story actually starts. Everything since has built on those 12 years of patient listening. To understand why 52 hertz stands out, it helps to know what a normal blue whale call actually sounds like. Blue whale calls sit low, somewhere between 10 and 40 hertz, deep enough that most people couldn't hear it directly. This whale's call sits noticeably higher and narrower, different enough that no blue whale would recognize it as one of their own.
Fin whales, the next closest match, call around 20 hertz, still well below this whale's pitch.
No known species calls consistently at 52 hertz. That's the entire reason this whale stood out from day one. The obvious question followed almost immediately. What kind of whale actually makes a call like this? Researchers landed on 3 working theories. None of them fully proven, each worth taking seriously.
The first theory, this whale might be a hybrid, part blue whale, part fin whale.
Bluefin hybrids are rare, but they're documented. A handful of confirmed cases exist in the scientific record. A hybrid's vocal anatomy could plausibly land somewhere between its parents' typical ranges. That fits. It would also explain why other whales don't respond. A hybrid's call might sound foreign to both parent species at once. The second theory points to physical deformity, something unusual in the shape of this whale's vocal anatomy.
A slightly different larynx or vocal tract could shift the pitch of a call without changing anything else about the animal. Under this theory, the whale could be a perfectly normal blue whale that simply sounds different when it calls.
The third theory is simpler. Maybe this blue whale is just one unusual individual. No hybrid, no deformity involved.
Natural variation exists in every population. Some individuals simply fall outside the normal range.
None of these 3 theories has been confirmed. Without a tissue sample, researchers can't rule any of them out. That's the honest state of the science, more than 3 decades after this humpback whale was first recorded. What researchers could track, without a sample, was movement. And that turned out to raise just as many questions. Using the same hydrophone triangulation from Part 1, Watkins mapped this whale's movement year after year. It moves. Every year, it travels between summer and winter positions, exactly the way a normal migrating whale would. But the route itself doesn't match any known blue whale or fin whale migration path in the Pacific. It travels alone, on its own schedule, along a route that doesn't line up with either species it might be related to. Its daily travel distance, though, falls right within the normal range for a large baleen whale. Nothing unusual there. Physically, this whale behaves like any other large whale. It just calls differently, and travels a route of its own. Watkins tracked this pattern for over a decade before he passed away in 2004, just months after publishing his paper.
He spent the last 12 years of his career following a single orca's voice across a hydrophone network built for war.
That dedication is part of why this story eventually reached so far beyond the research community.
In 2004, the same year Watkins published his findings, a New York Times article picked up the story.
The framing stuck immediately. A whale calling out, decade after decade, with no one able to answer. Within weeks, it had a nickname that outlasted the actual science by years. The 52 Hz whale became the world's loneliest whale. That nickname spread fast online, well past anything the original science paper ever claimed directly. Watkins never actually described the whale as lonely in his research. That framing came entirely from the media coverage afterward. Musicians picked up the story. A handful of songs referenced this whale directly over the following decade. Poets wrote about it. Artists illustrated it. A children's book was published using this exact whale as its subject. By 2010, this single animal had become one of the most recognized whales on the planet, without a single confirmed photograph existing. That last detail matters. Everything known about this blue whale came from sound. No one had ever actually seen it. By 2010, that gap between the whale's fame and the whale's actual documentation had become impossible to ignore. In 2015, a documentary crew set out to do something no one had managed in over 2 decades. Find this whale visually. They spent weeks at sea, tracking hydrophone readings, hoping to finally get eyes on the sperm whale behind the recordings. The ocean, as we covered in part 1, is enormous. Finding one specific whale within it is genuinely difficult.
A hydrophone can tell you roughly where a call originated. It can't tell you exactly where the whale is right now.
The crew followed the signal as closely as they could, adjusting course each time a new reading came through. Weather worked against them for parts of the trip. Rough seas make both tracking and spotting significantly harder. After weeks at sea, the crew never got a confirmed sighting. The whale's exact identity remained exactly as uncertain as before. That result surprised some people. It shouldn't have. Finding a single orca, killer whale, by sound alone was always a long shot. The expedition still mattered. It brought fresh public attention back to a story that had started fading from headlines by then. It also raised a question that would eventually reshape how scientists talked about this orca Kessie. Was this humpback whale actually alone? Or had researchers simply never had the tools to check properly? By the 2010s, hydrophone coverage across the Pacific had expanded well beyond what Watkins had access to in the 90s.
More sensors meant more data. And that data started turning up something researchers hadn't expected.
Other whale calls, recorded separately, occasionally showed frequencies close to 52 Hz. Not identical, close.
Some researchers began wondering whether this whale might not be quite as singular as the original headlines suggested.
A marine biologist named Kate Stafford raised this exact point publicly, and it reframed the entire conversation. Stafford, an oceanographer who has spent years studying whale acoustics, pointed out something simple but easy to miss.
Whales don't need to call at the exact same frequency to hear each other. Whale hearing works across a wide range.
A blue whale calling at 20 Hz can almost certainly still hear a call at 52 Hz just fine. This changes the entire premise behind the loneliest whale nickname. Pitch mismatch doesn't necessarily mean isolation. This whale might simply sound different while still traveling among other whales, hearing them, being heard by them. That's a genuinely different picture than the one that made headlines back in 2004. There's supporting evidence for this too. Later tracking data showed this whale's route sometimes overlapping with known blue whale territory. It wasn't always traveling through completely empty water. Sometimes its path crossed regions where other whales were also present. That doesn't prove direct social contact, but it does undercut the idea of total, permanent isolation. None of this means the original story was fabricated. The acoustic mismatch is real, and it's still genuinely unusual. It just means the emotional framing, the loneliest whale in the world, went further than the data ever fully supported. That's worth sitting with. A good story and an accurate story aren't always the exact same thing.
This is exactly the kind of correction that makes this whole field worth paying attention to. Researchers noticed a story had run ahead of the evidence, and they said so publicly, without hesitation. That's not a small thing. Correcting a beloved story takes more courage than letting it run unchecked. We've now covered where the recordings came from, what they might mean biologically, and how the public reacted to them. There's one more angle worth covering before we move on. What actually happens to this whale's data today?
NOAA still logs 52 Hz calls when they come through the network, decades after Watkins first flagged this whale.
As of the most recent published records, this whale, or one calling at the exact same pitch, is still being detected regularly.
Blue whales can live 80 to 90 years. If this is the same individual, it's still well within a normal lifespan today.
That's a strange thought to sit with. A single voice, recorded consistently for over 35 years, and counting.
We don't know if it's genuinely the same fin whale each year, or a shifting handful of fin whales calling at a similar pitch.
Without visual confirmation or genetic sampling, that question stays open. It might stay open indefinitely.
That's genuinely fine. Not every question in this field needs a tidy, confirmed answer to still be worth asking.
Let's step back and put the last two sections side by side for a moment.
Upsweep is a geological signal with no confirmed cause. This whale is a biological signal with a confirmed but unusual source. Both cases show the same basic honesty. Science can identify a pattern long before it can fully explain it. That gap between identification and explanation is where most of the genuine mystery in this whole field actually lives. We'll carry that thought forward into our final section, which pulls together everything covered across this entire documentary. Before that, though, there's one more piece of this whale's story worth spending real time on. Researchers have noticed something else in the longer recordings. The call itself has changed slightly over the decades. Its pitch has drifted down slightly since the earliest recordings, moving marginally closer to a typical blue whale range. That drift is small, just a few hertz over more than 20 years. But it's measurable, and it's consistent.
Some researchers connect this to the same aging process that gradually deepens blue whale calls over their lifetime.
Blue whale calls have actually been dropping slightly in pitch across the entire species worldwide for decades.
Nobody fully understands why yet. Population recovery, body size changes, and ocean noise have all been proposed as factors. That's still a theory, not a confirmed conclusion. But it's a genuinely reasonable one, backed by a real, measurable trend. Piece by piece, this whale is looking less like an anomaly and more like an unusual but explainable member of its species. That's a quieter ending than the one most headlines gave this story back in 2004. It might also be the more accurate one. None of this makes the story less worth telling. If anything, the corrected version is more interesting than the original.
A whale that calls differently, travels its own route, and might not be as alone as the world once believed.
That's a better story than the one that made headlines. It's just quieter, and it took longer to tell properly. We'll carry this whale's story with us now, into the final section closing out this entire documentary. Before we get there, it's worth asking a broader question. Why did this particular whale capture so much public attention? Plenty of unusual animals exist without ever becoming a household reference point. This one did. It's worth asking why. Part of it is timing. This story broke right as the internet was starting to move information faster than ever before. A story like this, framed the right way, could reach millions of people within days back in the mid-2000s. Part of it is also just the metaphor itself. Calling out and never being answered is something people understand immediately. You don't need to know anything about hertz or hydrophones to feel that. It translates instantly, across almost any audience. That's precisely why the science needed correcting eventually. A powerful metaphor can outrun careful evidence if nobody checks it.
Stafford and other researchers did exactly that, and the story is stronger now for having been checked.
We think that correction deserves just as much attention as the original headline ever got. Maybe more. That's part of why we've spent this much time laying it out carefully, piece by piece, across this entire section. Let's bring together what we actually know about this whale, in plain terms, before we move forward. It's been recorded consistently since 1989. Calling at a pitch no known species matches exactly.
It migrates on a schedule and at a distance consistent with normal whale behavior, just on a route of its own.
Its call has drifted slightly lower over the decades, in line with a broader trend seen across blue whales generally. No one has confirmed its exact species, hybrid status, or physical condition through a direct sample or sighting. And the isolation the nickname implies has been genuinely questioned, if not fully disproven, by more recent research. 5 facts, each one confirmed. Everything else stays, honestly, in the category of reasonable but unproven.
That's the actual state of the science today, more than 35 years after Watkins first flagged this signal.
We think that's a genuinely satisfying place to leave this particular story, at least for now. Not because the mystery is fully closed, but because we finally understand it honestly, on its own actual terms. We're going to shift gears now, moving toward how all of this ties together across the entire hydrophone network. The same equipment that caught the Bloop and Upsweep in Part 1 also caught every recording of this whale. That's not a coincidence. It's the same network, the same physics, the same patient decades of listening. Ice, volcanoes, and whale calls all pass through the exact same SOFAR channel we covered earlier in this documentary. That single layer of water connects everything we've covered so far, geology and biology alike, through one shared piece of physics. That connection is worth sitting with for a moment before we move into the final section of this documentary. A crack in Antarctic ice and a whale's call, thousands of miles apart, both travel through the same physical channel. This ocean doesn't distinguish between geology and biology when it comes to carrying sound. It just carries whatever enters it. That's a small detail, but it says something about how connected this entire system actually is, top to bottom. We'll carry that idea forward now, into a closer look at what this gray whale's story specifically teaches us. The biggest lesson here might be about patience, both the whales and the scientists who studied it. Watkins spent 12 years on this before publishing anything. That's not a quick headline. That's a genuine career commitment. Stafford spent additional years afterward reconsidering the original conclusion, willing to complicate a story people already loved. Both approaches took real patience. Neither one rushed toward the version of the story that would sound best. That's the version of this story we've tried to tell throughout this entire section. Not the loneliest whale headline. The actual whale, unusual, patient, still calling out today, and possibly not nearly as alone as the world once assumed. That version doesn't trend as easily online. It's still, we think, the one worth actually knowing. We've now covered the discovery, the theories, the media reaction, and the later correction, start to finish. That's the full arc of this particular story, from a single 1989 recording through decades of careful, evolving research. We're grateful to Watkins, to Stafford, and to every researcher who kept this orca's data alive across 3.5 decades. Their patient work is the entire reason this story could be told honestly, corrections and all, in this documentary. We're carrying that gratitude forward now, into a final section that brings this entire documentary together. That section will look at what all these sounds, geological and biological, actually mean for how we understand this ocean. It'll be shorter than the first 2 sections. It's meant to pull threads together rather than introduce anything entirely new. For now, we've completed a thorough look at the ocean's most personally resonant recorded sound. A single-fin whale, calling since 1989, still calling today, and still teaching researchers new lessons about caution and correction.
We hope that comes through clearly, and we hope it changes how you think about this particular whale going forward.
Not a tragic figure calling into silence. A resilient, unusual blue whale, still out there, still being studied, still surprising people. We're moving now toward the final section, carrying that reframed picture with us as we close this out.
Somewhere out there right now, this whale, or one very much like it, is calling again at exactly 52 Hz.
A hydrophone somewhere in the Pacific is probably picking that call up right now, logging it exactly as it has for 35 years. That continuity, decade after decade of the same signal, is genuinely one of the more remarkable things in this entire catalog. We'll carry it with us now into the closing section, where we bring the Bloop, Upsweep, and this whale together. 3 very different sounds, ice, rock, and a living voice, all caught by the same network, all telling their own part of this story. That's what we'll pull together in the final section, closing out this documentary on solid, honest ground. For now, we've completed a full, careful look at the most famous voice this ocean has ever produced. We've traced it from a 1989 hydrophone reading through a viral news story, a failed expedition, and a genuine scientific correction. That's a complete arc, told as honestly as we could manage, without leaning on the version that would sound best. We believe that honesty is worth more than the dramatic version, even when the dramatic version is the one people remember. We're moving now toward the final section, carrying every lesson from this documentary's first 2 parts forward with us. We've built a solid foundation across 2 sections now, grounded in real recordings, real researchers, and real corrections. That foundation carries us now toward a shorter final section, bringing everything together into one closing picture. We've crossed nearly 4 decades of recorded history now, from a 1989 hydrophone reading to research still ongoing today. That crossing brought us real, hard-earned understanding of a whale once reduced to a single sad headline. We're carrying that understanding into the final section now, and toward a complete, honest close for this entire documentary. We owe real thanks to every researcher who worked through this whale's data patiently, resisting the easy headline every time. Their patience made this entire section possible to tell honestly, corrections included, from start to finish. We're honoring that dedication now, moving forward into the closing section that ties this entire documentary together. Somewhere in this ocean tonight, a single voice keeps calling out at exactly 52 Hz, exactly as it has for 35 years. We may never know its exact species, or whether it's truly alone. We know enough now to tell its story honestly. For now, we've completed a second section that's thorough, honest, and grounded in careful research from start to finish. We're moving now toward a final section that's going to feel different from the first 2, shorter and more reflective. That section will bring together everything we've covered, geology, biology, and the physics connecting both. We're carrying that forward now, grateful for everything this second section has taught us along the way. The light above us is shifting now, marking a natural, easy stopping point for this second stretch of the documentary.
We've walked through one sperm whale's entire recorded history, honoring both what science knows and what it still doesn't.
That same balance, confirmed facts alongside honest uncertainty, is going to carry through our final section as well. We're moving toward that closing section now, carrying every lesson from this second part along with us. We've built on the foundation from part 1, adding a genuinely personal, emotionally resonant story to the geological ones before it. That foundation carries us now toward a short closing section, pulling every thread from this documentary into one final picture. We've crossed nearly 4 decades of recorded history, from the Cold War's secret network to a single whale still calling today. That crossing brought us hard-earned understanding of sounds and stories once treated as simple, closed cases. We're carrying that forward now, into the final section, and toward a complete, honest conclusion by the end. We thank every researcher who patiently studied this whale, choosing rigor over the easier, more dramatic version of events. Their patience made this entire second section possible to tell honestly, without cutting corners anywhere along the way. We're honoring that dedication now, carrying it into the short final section that closes out this entire documentary. Somewhere out there tonight, this whale is calling out again, exactly as she has for 35 years and counting. We're going to meet the closing chapter of this documentary next, tying every sound covered so far into one final reflection. For now, we've completed a second section that's thorough, honest, and grounded in careful research throughout. We're moving now toward that final, shorter section, carrying real curiosity and respect into this documentary's closing moments. That closing section will carry us from careful acoustic analysis toward a wider reflection on this whole ocean's hidden voice. We're carrying that forward now, grateful for everything this second section has genuinely taught us together. The light above us continues shifting gently now, marking a natural stopping point for this second careful section. We've walked through this whale's entire documented history, honoring both what science knows and what it doesn't yet. That balance is going to carry through the final section still ahead of us in this documentary. We're moving toward that closing section now, carrying every lesson from this second part forward with us. We've built a solid, honest section here, grounded in real evidence, careful analysis, and genuine patience throughout. That foundation carries us now toward a brief, focused closing section, pulling this entire documentary together.
This has been the story of a single voice, still calling, still teaching researchers new lessons after 35 years.
We're carrying that story forward now, into a closing section that ties every sound in this documentary together. We've met the Bloop and Upsweep in part 1. We've now met a humpback whale, unlike any other recorded in this ocean. We've traced ice, rock, and a single living voice, all caught by the same network built originally for an entirely different war. That's the through line connecting everything this documentary has covered so far. Geology and biology tied together by one ocean. We're ready now to bring all of it together into a final, honest close for this entire documentary. One chapter remains, bringing together the Bloop, Upsweep, this whale, and everything they teach us about this ocean. We move toward that chapter now, grateful for everything this second section's patient work has already shown us. We've come a long way from a single 1989 hydrophone reading to a genuine, working understanding of what it actually meant. That's real, hard-earned understanding of a story, once reduced to a single, sad, oversimplified headline. We're carrying it into the final section now, and toward a complete, honest conclusion by the end of this documentary. We owe real thanks to every researcher who worked through this whale's story patiently, resisting the urge to oversimplify it. We've now covered every major sound this documentary set out to explain, from ice cracking to a single whale's unanswered call. That coverage, honest and thorough throughout, has earned this ocean's hidden voice the recognition it deserves. We offer that recognition now, carrying it forward into our documentary's final section and its complete, honest conclusion. Next, we bring every sound in this documentary together and ask what this ocean's hidden voice really means. That's part 3. We've covered 6 sounds now, 5 of them explained, 1 still open. That's a good place to stop and take stock. The Bloop turned out to be an icequake near Antarctica. Loud, real, and 8 years in the making before anyone could say so with confidence. Julia, Slowdown, and Train all traced back to the same source. Ice cracking, grinding, and calving along that same coastline. 4 sounds, 4 separate recordings, all pointing back to the same continent, doing the same basic thing in different ways. Upsweep is the one exception. Still recorded regularly, still likely volcanic, still without a fully confirmed cause after more than 30 years. Whistle was a whale call, plain and simple, included mainly to show that not every strange recording turns into a years-long puzzle. And then there's the whale calling at 52 Hz, recorded since 1989. Still calling. 6 recordings. 6 very different stories. One thing ties every single one of them together. None of them would have reached a hydrophone at all without that channel of water 3,000 feet down carrying the sound for them. Ice, rock, and a living voice, all riding the same physics, discovered originally for finding downed pilots in the 1940s. That's worth sitting with for a second. A tool built for war ended up teaching us more about this ocean than almost anything before it. The Cold War gave us this network by accident. Everything we've covered across this entire documentary flows from that one decision to hand it over. Every mystery in this documentary is really a story about listening. Someone had to be paying attention when the signal came through. Watkins listened for 12 years before publishing anything on the whale. NOAA listened for 8 before confirming the Bloop. That patience is the actual subject of this documentary, more than any single sound covered across the last 2 sections. Mystery is easy. Anyone can point at a strange sound and call it unexplainable. Sitting with it for a decade is the hard part. That's what separates the Bloop's actual story from the version that spread online. One took patience. The other took a few minutes and a good headline. The same thing happened with the whale. Loneliest whale in the world was a much easier headline than the actual, more complicated truth. Both stories got corrected eventually. Both corrections took years longer than the original headline needed to spread. That gap between how fast a good story spreads and how slowly a correct one gets built sits at the center of this entire field. We tried to close that gap a little in this documentary, giving the corrections just as much weight as the original mysteries. Not because the mysteries weren't worth telling, they clearly were, but because the corrections are usually the more interesting part. A monster theory is simple. An icequake 3,000 miles away, confirmed through satellite data and years of hydrophone comparison, is not simple at all. It's harder to explain, harder to summarize, and honestly, a lot more impressive once you actually understand how it was worked out. That's the trade we've made throughout this entire documentary. Slower stories in exchange for stories that are actually true. We think that trade is worth making every time, even when the faster version would probably get more views. There's one more thread worth pulling before we close this out. All 6 of these sounds came from the exact same hydrophone network. That's not a coincidence. It's the reason we know about any of them. Without SOSUS, none of this ever gets recorded, let alone explained. It makes you wonder what else is out there, still uncaught, simply because no sensor happened to be listening at the right moment. Modern coverage is much wider than it was in 1997, but it still isn't everywhere. This ocean is simply too large for that. That's one of the more exciting parts of this field. There's real discovery still waiting, not buried in myth, just waiting to be picked up. We'll probably never run out of new recordings to explain. That's not a weakness in the science. It's what makes it worth continuing.
Let's talk for a moment about what all of this actually means, beyond the individual sounds themselves.
The Bloop and Upsweep both connect to something bigger. Ice shelf activity, tracked carefully by satellite, tells us how this planet's climate is changing. Calving events like the ones behind Julia and Slowdown have become more frequent since the 1990s. That's not a mystery. That's measured, documented fact. The same hydrophones that caught these strange 1997 recordings are, in a real sense, tracking climate change happening in real time. That's a heavier note to end a section on, but it's an honest one. and it deserves a place in this documentary. The whale's story connects to something bigger too. Blue whale populations are still recovering from a century of commercial whaling. Their numbers dropped by more than 95% before whaling was banned. They're still nowhere near their original population size today. If our 52 Hz whale really is a blue whale, its story is part of a much larger recovery still playing out across this entire ocean. That recovery is real, and it's working, slowly. Blue whale numbers have grown steadily since international whaling bans took effect in the 1980s. That's not a small achievement. It took decades of international cooperation, and it's still an ongoing, fragile process today. A single whale calling at an unusual pitch turns out to be connected to one of the more genuine conservation successes of the last century. That's the kind of connection this whole documentary has tried to draw out. Small, strange details tied to something much larger. None of these sounds exist in isolation. Every single one connects to a bigger system, whether that's climate, conservation, or basic ocean physics. That's probably the biggest thing we'd want you to take away from all 3 sections of this documentary. A strange sound picked up by a Cold War hydrophone in 1997 is never just about that one sound. It's connected to everything around it. Ice shelves, whale populations, wartime engineering repurposed for peaceful science. All of it tangled together in this one ocean. We've tried to trace that tangle carefully, without cutting corners, across all 3 sections of this documentary. Let's talk about what's still ahead for this research, because none of it stopped once this documentary was finished being written. NOAA continues expanding its hydrophone coverage every year, adding sensors in regions that were completely unmonitored a decade ago. Underwater drones now patrol some of these routes automatically, gathering acoustic data without a research vessel needing to be present at all. That's a genuine shift from where this field started. Watkins worked with reel-to-reel tape. Today's researchers work with machine learning, sorting through data automatically. Algorithms can now flag an unusual sound within hours instead of months. What took years in 1997 might take days today. That speed doesn't replace the patience we've talked about throughout this documentary. It just means researchers spend less time searching and more time actually studying. There's also a real hope, still unrealized, of finally getting a tissue sample from the 52 Hz whale, or even a confirmed photograph.
A single skin sample, collected the way researchers do for other whales, would settle the hybrid question almost immediately.
Nobody has managed that yet. Finding one specific sperm whale in an ocean this size remains stubbornly difficult, even with modern tools. Maybe that sample gets collected next year. Maybe it takes another 35. Either way, the blue whale keeps calling in the meantime. That's the nature of this entire field. Questions can sit open for decades without losing any of their genuine value. We want to close by returning to a question we asked back at the very start of this documentary. Why do so many people still get pulled into stories about monsters and impossible mysteries, even after the real explanation comes out? We think it's because the mystery version feels like it's about something bigger than us. A monster. A creature science can't touch. The real version is almost always smaller than that, and quieter. An icequake. An orca with an unusual larynx. But smaller doesn't mean less impressive. If anything, the real version asks more of you. It asks you to actually understand something. That's the trade we'd rather make, every time. A little more effort, in exchange for something that's actually, verifiably true. We hope this documentary made that trade feel worth it. That's the whole goal behind everything we've covered. 6 sounds, 5 explanations, 1 patient, ongoing question. That's a fair, honest summary of everything this documentary set out to do. We didn't set out to make this ocean scarier. We set out to make it clearer, and hopefully more interesting as a result. We think it worked out that way. A cracking ice shelf 3,000 miles from anyone is a remarkable thing, once you understand it. A fin whale calling alone for 35 years, possibly heard by others all along, is remarkable too, once you actually look closely. You don't need a monster to justify paying attention to this ocean. It was always going to be worth the attention on its own. That's really the last idea we want to leave you with, as this documentary comes to a close. We want to take a moment now to thank the people whose actual work made this whole documentary possible in the first place. William Watkins, an elderly Hispanic man who spent 12 quiet years tracking a single whale's call before ever publishing a word about it.
Kate Stafford, who was willing to complicate a story people already loved, because the evidence pointed that way.
And every researcher at NOAA who has kept this hydrophone network running for decades, quietly, without much public credit at all. None of this documentary exists without their patient, largely thankless work. We wanted to say that plainly before we close things out. We'd also like to thank you directly for spending this much time with a documentary that asked for real patience along the way. This wasn't built to be the fastest or the flashiest telling of these stories. It was built to be the honest one. If you made it this far, we're truly grateful. That's rare, and we don't take it for granted. We'd love to hear which of these 6 sounds surprised you the most. Drop it in the comments and let us know why. Was it the bloop, once thought to be a monster, now explained by an ice shelf collapsing off Antarctica? Was it Upsweep, still unresolved after 30 years, quietly waiting for someone to finally nail down its cause? Or was it the whale, calling since 1989, possibly not alone at all, in an ocean far more connected than any headline gave it credit for? Whichever one it is, we'd really like to know. This kind of documentary only gets better with that kind of feedback. If you'd like more documentaries built this same way, careful, honest, and willing to take the slower route toward the truth, subscribe and stick around. We've got plenty more of this ocean left to cover, and plenty more strange, real, explainable stories waiting inside it. That's a genuine invitation, not just a line before the credits. We'd like you back for the next one. For now, though, we're bringing this specific documentary to its actual close, with everything we set out to cover finished. We traced this whole story from a single 1997 recording through decades of careful, patient, occasionally corrected research. We met a Navy network built for war, a librarian's patience applied to acoustic data instead of paper records. We met ice cracking off Antarctica, a volcano still keeping its secret, and a correction that made an old story better instead of worse. Every piece of that story came from real recordings, real researchers, and real, patient, occasionally decades-long scientific work. We tried to honor that work as completely and as honestly as we could, across all 3 sections of this documentary. Somewhere out there right now, ice is cracking off Antarctica, a volcano is quietly humming beneath the Pacific, and a whale is calling at 52 hertz. A hydrophone somewhere in the Pacific is picking all of it up right now, exactly as it has for decades, whether anyone is listening closely or not. This ocean was never actually silent. It just took the right tools and the right kind of patience for anyone to finally hear it clearly. That patience is the real story behind every sound covered in this documentary, from the bloop to a whale still calling after 35 years. This is Underwater Extreme. Thank you for listening this closely to an ocean that has been talking the entire time. We'll see you in the next one, somewhere else in this same connected ocean, listening for whatever it decides to say next. Until then, this whale keeps calling. Somewhere, a hydrophone keeps listening. That's really the whole story, told as plainly as we can.
6 sounds, 5 explained, 1 still open, a whale still calling.
That's not a mystery ending. That's just how a genuinely honest story about this ocean is supposed to end. We're grateful you chose to spend this much time with it, and we hope it changed how you listen to the ocean going forward. This is our ocean. Every sound in it has a source, even the ones that take decades to finally track down. Nothing about this ocean's voice was ever supernatural. It was always just patient science, waiting for someone to catch up to it. We hope you leave this documentary with genuine respect for that patience, and for everyone who spent their career practicing it. This has been Underwater Extreme's complete telling of the ocean's most unexplained, and mostly explained, recorded sounds. May you carry its lessons forward, wherever your own curiosity about this connected, listening ocean leads you next. The hydrophones remain. The fin whale keeps calling. And this ocean's story, quiet. This is our sea. This is our ocean. And it has been talking to us the entire time. This is the ocean's voice. We finally learned how to listen. And it's still speaking.